All right, welcome back, everybody. We're going to do section 5, 6 today, but again, starting the video a little early so you guys can see the key from the homework from last night. So again, if we haven't already done so, please submit that. I know I said that already in class, but if you haven't already done so, if you're watching the video, please submit it, and I can give you credit for it. So here's the key for the assignment. There's page 353 to 354. And those numbers, those evens. Okay, so go ahead and start checking. I'll answer questions where we need to. Oh, I guess I gotta unfreeze the other board there. Does that work? No, you gotta go with There we go. Much better. Just as a reminder of the rundown for the schedule for the next couple weeks or so. We got section 5, 6 today, practice test tomorrow. Today's Wednesday, tomorrow's Thursday. Practice test, I'll give you the practice test tomorrow. I'll give you a bunch of in-class time to work on it. We'll go over it on Friday. We'll actually do our test on Monday. I know Monday tests suck, but we have to. Just because we're so close to exam time. We have our 5-1 to 5-6 test on Monday. That will be the last big summative grade of the grade book for the 9 weeks. I think there's probably going to be another one, but not going to be as big as 5-1 and 5-6 test. And then we'll do sections 5-7, 5-8, and 5-9 on Tuesday, Wednesday, Thursday of next week. And then by Thursday, I will be giving you the practice exam. And then Friday, go over it. Monday, go over it. Tuesday, go over it. Wednesday, go over it. And then we have our exam next Thursday, not next Thursday, but that Thursday and Friday of that last week before break. So we keep scrolling down. Does anybody need 18 to 24 while I'm still there? Okay. Here's 26, 28, 30, 32, and 34. Okay. Anybody still need 26 or 28? Okay, just scrolling down a little bit more here so we can see 44, 46, and 48. That's an I sneaking in on 48. You don't see that. Okay, anybody still need 30, 32, and 34? Okay, keep scrolling down here. Oh, we can almost see, oh yeah, we can get the bottom of 50 there. Perfect. 54 is the last one, right? Oh, 56, oops. Oh, 56 is right there. Okay, we got it. Cool. All right, questions. Ask me some questions. I like doing math in the morning. Go ahead.
Number 28.
Number 28, okay. I'm just gonna scroll back up to 28 just to see the original problem here. X squared plus 2x plus 3. F of x equals x squared plus 2x plus 3. Again, let me scroll back down and see where anybody still checking this stuff here. Okay, so x squared plus 2x plus 3, I want to solve, right? I want to find the zeros. Remember, when I say find the zeros, it's a different type of problem than when I say find the vertex, right? When I say find the zeros, I say x squared plus 2x plus 3 equals 0. And I just have to double check to make sure that this is that type of problem. Okay, yeah, it is. Okay, good. All right, so we find the zeros by setting it equal to 0, and then we try to, our first line of defense is to try to factor. And this one almost looks like it factors. It's like extremely tempting to try to factor this one. Factors of 3 that add to get to 2. You're always like, oh, -1 and 3. Oh, wait, it's a positive 3, not a -3. Oh, so close. But you can't. So we have to complete the square. The -3 goes on the right side now. And now we add to both sides. Half of 2 squared 1. Okay, so I add 1 to both sides. This gives me an x plus 1 squared is equal to -2. Square root -2. X plus 1 is equal to plus or minus. Now, if I square root 2, it's going to say radical 2. So remember the negative, like if I could just write the intermediate step of doing that, right? Which basically means that this negative underneath the radical comes out as an I, plus or minus I radical 2. Pay attention, make sure that you're not putting that I in front of the plus or minus. It goes directly just in front of the radical, not in front of the plus or minus. I subtract the 1 over to the other side, -1 plus or minus I radical 2. Okay. What does this tell you about the parabola? That it has no x-intercepts. Has no real x-intercepts, I guess I should say. There are x-intercepts. They're just graphed on a non-real plane rather than a real plane, which you might cover in further math classes down the line, like how it's all that. What other questions do we have? What else do we want to go over? Yes, sir. Thank you.
48.
48. Okay, so we got 2x squared plus 12 and a half. 2x squared plus 12 and a half equals 0. Oh, this one's weird because it's got the decimal. Right? This is kind of funky. This one takes like a weird technique to solve this one. 2x squared is equal to -12 and a half. Divide by 2. -12 and a half. Oh, and a half. I think that's 6.25, right? Oh my gosh, what the heck am I doing? 12 and a half divided by 2. And then I would go to square root it, so I would have plus or minus the radical -12 and a half over 2. Now here's the deal though, I don't like decimals within fractions. Okay, I don't like decimals within fractions. So an easy way to get rid of a decimal within a fraction, if it's 0.5, is to just double it. And it's really convenient in this case. -12.5 doubled is -25. 2 doubled is 4. So it's like, oh, okay. So it's actually, they actually are perfect squares, right? Aren't these two fractions equivalent? Right? If I divide top and bottom by 2, which I can do that, if I divide top and bottom by 2, I get -12 and a half over 2. So now when I actually square root it, I actually square root it. It's 5 halves, and because there was a negative underneath the radical, 5 halves off. Make sense? This is the weird step is that one right there. I get that. It's kind of funky. All right, questions on that? Anything else on the homework that we'd like to talk through or go over? Okay. All right, let's get to our notes then. Oh yeah, that's right. Coming over to pick up the guided notes. So no guided notes. So get out just some scrap paper or some notebook paper, whatever. There's no guided notes because there's not really a lot of prep to these problems. Okay. Remember back when we were learning factoring, and I said, well, factoring only works some of the time. And then we introduced completing the square because the good part about completing the square, even though we would all agree that it's more difficult than factoring, the good part about completing the square is that it works all the time. No matter if there's 1 0, 2 zeros, or no zeros at all, or maybe they're not real, right? Completing the square works every single time, no matter what, no exception. There is another method that works every single time. It's the quadratic formula. Okay? It's the quadratic formula. We've learned several methods for solving quadratic equations. We learned graphing too, right? We could just graph the the quadratic and find where the zeros are, and just the x-intercepts. We could make a table, we could factor, we could use square roots. If there's no b term, right, that's an easy method. Just solve directly for x, like this one here on the board. There was no b term, so we can just get everything to the other side, then square root it and see what happens. That's using square roots. And then we talked about completing the square, obviously. Another method is to use the quadratic formula, which allows you to solve a quadratic equation in standard form. Got to be in standard form. By completing the square on the standard form of a quadratic equation, we can determine the quadratic formula. This is the quadratic formula. I'll give you a minute. If you're watching from home, pause it and write this down. Go ahead and write that quadratic formula down. That's a biggie. That's one that you're going to need to know. We know what A, B, and C are. So that first line is just kind of like setting the stage, prefacing that, if we know that ax squared plus bx plus c equals 0, right? If we have it in standard form, where A, B, and C are our coefficients, well, A and B are our coefficients, C is our constant, then the solutions, or the roots of the equation, are x equals negative b plus or minus, and that's where the two different ones come in, right? The plus or the minus. Negative b plus or minus the square root of b squared minus 4ac, and then you divide that entire thing, not just pieces and parts of it, divide the entire thing by 2 times a. That's the quadratic formula. Back in high school, my algebra, she always sang it in Pop Goes the Weasel. The opposite of b plus or minus the square root of b squared minus 4ac. Yeah, she finished it. All over. I was giving it suspense, like the Pop Goes the like all over Tuesday. Pop Goes the Weasel, But make sure it's all over to it. All over to it. That's a very, very common mistake. People just put the square root with the 2a underneath it. It's the entire thing. Negative b plus or minus square root of b squared minus 4ac, all over 2a. Yeah? Okay. You want to know the cool thing to this? Is that you guys are going to have to prove this formula. You're going to have to derive this formula. Okay? And how are we going to do that? Well, what we're going to do is complete the square on this guy. Okay? This is what's called not a geometric proof, but an algebraic proof. Not necessarily needing 2 columns, because there's not really theorems that we're going to use for this. What we're using are algebraic properties. Now, the nice thing about algebraic proofs are those are ones that you don't necessarily need to give reasonings for, because they're kind of common sense. Like, I'm going to divide both sides by the same number. I'm going to add both sides to the same, add the same thing to both sides, or whatever. Those are very common sense things. So you don't really need to provide a justification. That's why this is not going to be like a 2-column proof. It's going to be more like an algebraic proof, where you basically just show in lineage one step to the next. Okay? So basically what I'm going to do here is, given ax squared plus bx plus c, we're going to prove the quadratic formula. Now here's the thing. I'm going to make you do this on the test. You want to see the back page of your test? I'll show you right now. Sorry, I'm not going to turn the camera on and show the folks at home. But I just copied them off. But look, here's the back page of your test. Given ax squared plus bx plus c equals 0, derive the quadratic formula. So you're going to have to do this on your test all by yourself. I'm just showing you right now. Look, it's 11 points. It says underneath that clip, it says show steps. Yeah. The reason I can't put a proof, because normally you guys see a proof and you're like given and proof, right? I say given this. If I had put this on your test, prove x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, well, that kind of defeats the purpose of making you memorize the quadratic formula, because I would be giving you the quadratic formula, right? So what I'm asking you to do here is just, given that, show how we go from this weird thing, standard form, to the quadratic formula. Okay, so that's why you don't see a prove statement. All right, given ax squared plus bx plus c equals 0. Let's start here by completing the square. I'm just going to rewrite because we always rewrite our given statement, right? Okay, let's move, we always move our constant over to the other side when completing the square, right? So let's do that. Ax squared plus bx is equal to negative c. So we just subtract the c over to the other side. And then, okay, so what's holding me back from completing the square here? What's stopping me from completing the square? Why can't I complete the square just yet? The a. Good. The a term. What do we normally do? Like if this was a 2x squared, what would I do with that 2? Divide it through, right? I'm going to do the same thing, but now this a is just an arbitrary number, so I'm just going to call it a. Divide through by a. And everybody gets divided by a. Everybody. So that leaves us with an x squared plus b over a. X is equal to negative c over a. Okay. So I need to do some preliminary work here. I need to figure out what I need to fill in that blank, right? I need to complete the square by filling in this gap that I have. Now, what fills in this gap? So I'm going to come off to the side, and I'm going to do some preliminary work here. I'm going to say, okay, b over a divided by 2 is equal to something squared, right? Because my b term in this case is actually b over a, right? B over a. We talked about this yesterday. What's the quick way to taking half of a fraction? Doubling the denominator, right? Doubling the denominator. So it's actually going to be, because honestly, isn't dividing by 2 the same thing as multiplying by 1/2, right? So 1 times b is b, a times 2 is 2a. So that gets added to both sides. Well, what is that? That is b squared over 4a squared. Everybody gets squared. B squared over 4a squared. So that's what gets added. Oops, not 4a squared. That gets added to both sides. That's what fills in my gap. That's what completes the perfect square on the left side. So it factors now. Remember that I'm not even going to think about what factors in from that add together to get the middle number, because remember it's always b over 2. It's always that b over 2, in our case b over 2a. So x plus b over 2a is equal to squared is equal to negative c over a plus b squared over 4a squared. Remember, show all steps. So I want to just keep plugging away. Now, I've got some other side work to do, right? I have to add these two fractions together, right? Which requires common denominators. So I'm going to come off to the side again, and I'm going to do negative c over a. Actually, you know what? I'll go step by step here. I don't need to come off to the side anyway. X plus b over 2a squared is equal to. Now, this just basically means I have to keep writing the left side. I have to get common denominators with those two fractions. Okay, well, to do that, I need this left side to look like a 4a squared on the denominator, right? This is going to be my common denominator. Because this one already has an a. I can make it look like 4a squared pretty easily. What do I multiply a by to make it look like 4a squared? Well, I put the 4 down there by multiplying by 4. And how do I raise it to the next power? Multiply by a. So I multiply this here by 4a over 4a. You don't have to show that work. Okay, I'm just showing you guys just to make sure you know how to do it in your head here. So I'm going to have 4a times negative c, or negative 4ac. All that was getting common denominators. I I needed another 4a in the denominator on the left side, so if I multiply 4a in the denominator of the left, I have to multiply 4a to the numerator on the left. Okay, now that I have common denominators, I can combine the terms. So this is x plus b over 2a squared is equal to. Now, look what I can do here. I can just take negative 4ac plus b squared over 4a squared. Okay, it's starting to take shape a little bit. I'm actually going to change the order because I don't like to lead with a negative in that top of the numerator there. So I'm going to rewrite the left side, x plus b over 2a squared is equal to, and I'm going to write b squared minus 4ac, oops, that sounds familiar, over 4a squared. Okay, at this point, I've simplified the right side as much as I possibly can. We square root the other side. We square root the other side. We start chipping away to get x completely alone. So that means I've got x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. Don't forget the plus or minus. That's pretty important. And now at this point, if I've got a fraction, if I've got a square root on a fraction, I can square root both the numerator and the denominator separately. How does that help us, you say? Well, because the denominator is actually a perfect square. So I've got x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac, and then I would write the square root of 4a squared. But what's the square root of 4? 2. What's the square root of a squared? A. So it's actually a perfect square. Okay, the right side's fully simplified, so let's subtract over the b over 2a. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And look at that, we've got common denominators already. I don't need to do any more algebraic work, just combine. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's how the quadratic formula is created. You basically complete the square on standard form. That's what you do when you're doing the quadratic formula. You don't really realize when you're working with the quadratic formula that you've actually just completed the square. Every time you use the quadratic formula, you're technically completing the square. You just don't realize it. So that's the proof. You will need to recreate that on the back page of your test. Okay. I've had several students try to turn in their test forgetting to go to the back page. So don't let that be you. Okay. A couple things that I want to show you here. Well, one thing basically. This is kind of interesting. What is that? What did I just circle there? That's an important formula that you should know. What is that? Negative b over 2a. It's not the c value. It's the axis, right? Isn't that the axis of symmetry? Negative b over 2a. Okay, so this is kind of interesting here. Let's kind of analyze this step right here. This is our axis of symmetry. This is our center line. And I'm adding and subtracting some value away from that center line. Oh, so this is kind of interesting. This is basically the deviation away from the center line for our zeros. Right? This is our center line, and this is how much it moves left or right from our center line. Okay? I just think that step is actually really cool. It shows us our axis of symmetry and moving right and left a certain amount to show both zeros. All right. Again, the meat and potatoes of this is that I really want to solve for x to any zero or for any quadratic to show you that it's possible for any quadratic. So let's find the zeros. X squared plus 3x minus 7. Okay, so my first step is to set it equal to 0. x squared. Oh, I guess I don't know. I don't really need to set it equal to 0. Like you could see your a, b, and c values, right? Especially if this is in function notation. A is 1, b is 3, c is -7. I would always set that up for yourself. Please don't skip that step. I know you guys are smart people, but please don't skip that step, because I will tell you, 9 times out of 10, when I see mistakes on a quadratic formula problem, you probably just like drop the negative somewhere. And it's probably right at the beginning right there, like you accidentally made that +7 instead of -7. Okay? But if you write it out for yourself like this, start it off right away, set it up, you might not drop that negative. Okay, x equals the opposite of b, -3, plus or minus the square root of b squared, 3 squared is 9, minus 4ac, all divided by 2 times 1, 2a. Okay, let's keep, now, where do we go first? Order of operations tells me that this is a big fraction, so I have to chip away at the bottom and the top. The bottom is fully simplified. So I have to chip away at the top. So I'm looking into the top and I see, okay, what's the first thing I have to do there? The square root. So you always start at the square root. You keep going underneath the square root until you can't anymore. -3 plus or minus the square root of, I've got 9, and I'll go into my calculator here. 9 minus 4 times 1 times -7. 37. All over 2. And then you would say, okay, can I simplify the square root of 37? Can I simplify the square root of 37? 37 is prime, right? So I can't simplify it at all. Okay, so if I can't simplify it, now, don't get me wrong, could I make it a decimal if I really wanted to? I could, right? This is positive underneath the radical. I could make this a decimal. I could actually figure out where the roots are if I really wanted to. But I can't simplify the square root. I would then look to see, okay, if I can't simplify the square root anymore, can I simplify this fraction? Do those have any common terms? No. So I'm done, folks. I am done with that problem. -3 plus or minus the square root of 37, all divided by 2. I'll tell you what, completing the square with that one would be a bear. But it's actually not too bad when we work with the quadratic formula. Let's try another one. Please, again, appreciate the difference between completing the square. Like, do you notice now that I would have a 2 out front? I would need to divide through by that 2. The middle term would be okay because that would just be -8, but then I would have, on the other side, I would have a 27 over 2 sitting up there. No, thank you. No gracias. Is that how you would say that in Spanish? No gracias. No, thank you. Okay, so A is 2, B is -16, C is 27. Okay, let's sing our song. The opposite of b plus or minus the square root of. Be careful. -16 squared. What happens when you square a negative? It becomes positive. -16 squared. So 16 squared is 256. So it's positive 256. I should check that. It's early in the morning. Okay, good. B squared minus 4a, oops, no a, a2, c, all over 2a. There we go. Chip away underneath the radical. 256 minus 4 times 2 times 27. 40. 16 plus or minus the square root of 40. All over 4. Right? Okay, keep chipping away the radical. Can I reduce down the square root of 40? Yes. 4 times 10. 4 is a perfect square. So it's 2 radical 10. 2 radical 10. 16 plus or minus 2 radical 10 all over 4. Now, can I simplify that further? Yes. And here's how. Remember, like back in chapter 1, when we were working with those big fraction reducing radical problems, when we had a big fraction and we used that technique of splitting apart the fraction? Let me do that same thing. X is equal to 16 over 4 plus or minus 2 radical 10 over 4. We give the denominator to both parts. Okay, so that means we've got 16 over 4 is 4. And then this 2 over 4 gets us a 1/2. Can I reduce the 4 with the 10 on the inside? No. Things inside are with things inside, things outside are with things outside. So 4 plus radical 10 over 2. And that's my answer. Please don't try to make that radical 5. It doesn't work like that. That would have to be underneath the radical. That 2 would have to be underneath the radical to reduce it. Yeah. No, sorry. Plus or minus. Questions about that? Again, even though there was more steps, I feel like that was so much easier than completing the square. In my opinion. My professional opinion. Let's try this one. 4x squared plus 3x plus 2. 4x squared plus 3x plus 2. A is 4, B is 3, C is 2. Again, people, think about how difficult this would be to complete the square. I would need to divide through by a 4, leaving me a 3/4 as my b value. And then I would need to take half of that and then square that. Yuck. No, thank you. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we have, let's keep chipping away, -3 plus or minus the square root of. We've got 9 minus 4 times 4 times 2. Ooh, -23. Why did I get so excited there? What am I going to have to write now? What's that? Imaginary number. Square root of negative. Now, can 23 break down? No. So the only thing that we can do to break down that square root, -3 plus or minus I radical 23 all over 8. I'm going to box this, and I should check one more thing to make sure that if I broke this apart, would I be able to reduce this -3/8? No. That's why I boxed that. Again, appreciate how much more difficult this would have been to complete the square. Okay, so the last thing that we're going to talk about is this thing called the discriminant. Okay, the discriminant. How did we know that this was going to come out non-real? Because there was a negative underneath the radical, right? There was a negative underneath the radical. That's how we knew that this was going to come out non-real, right? How did we know that this was going to come out as two different solutions? Well, there was a positive underneath the radical, right? So this thing underneath the radical is actually pretty important. It's called the discriminant, okay? The discriminant. B squared minus 4ac has a special name called the discriminant, and it actually tells you whether you're going to get real solutions or not. Okay? It tells you whether you're going to get real solutions or not. It tells you whether solutions are going to be either real or non-real. Okay? If b squared minus 4ac becomes positive, then you're going to get two real solutions. Obviously, you could square root it and you get a decimal, sure. If b squared minus 4ac comes out to be negative, you're obviously going to get non-real solutions. If b squared minus 4ac comes out to be 0, what's going to happen? If b squared minus 4ac goes to 0, one solution, right? Because that would mean that this would be 0. So the plus or minus 0 is really not going to do anything, right? You're basically going to get negative b over 2a, which is your axis of symmetry, okay? So here we are to summarize that. Discriminant part of the quadratic, blah, blah, blah. To summarize that, get out of my way, get out of my way, get out of my way, okay? You could write this in other methods here. If b squared minus 4ac is greater than 0, so basically b squared, I should really write this in red. B squared minus 4ac positive, you're going to get two zeros, two real. B squared minus 4ac is equal to 0, you're going to get one real. B squared minus 4ac negative, you're going to get no real. Two non-real. You can never ever have one non-real. That's not an option. Okay? And we'll talk about that a little bit later on in chapter 6. You always have to have a conjugate pair of zeros. Remember I was talking about complex conjugates yesterday? You can never have one non-real. If you have one complex number as a solution, the other conjugate pair of the complex number would be a solution as well. But these are the options here. B squared minus 4ac being positive, b squared minus 4ac being 0, b squared minus 4ac being negative. When the discriminant is positive, there's two real. When the discriminant is 0, there's one real. When the discriminant is negative, there's two non-real. Okay. Now, does this tell me what they are? No, but it's kind of like a quick check. Like if you're saying, okay, will I have solutions? Will this be defined? Will this be real? Check b squared minus 4ac. If b squared minus 4ac is positive, yeah, you're going to have real solutions. Well, positive or 0, right? B squared minus 4ac being positive gets us two real. B squared minus 4ac equaling 0 gets us one real. So I would get real solutions in these two options. But this one I would not. B squared minus 4ac being negative would put a negative underneath the square root. So meaning here, if I have this equation, I want to figure out, am I going to have solutions? Did I ask what the solutions are? No. I'm just asking, what are the type and number? So let's subtract the 12x over to the other side. So x squared minus 12x plus 36 equals 0. Set it equal to 0 so I can see my A, B, and C values. Again, all I did was just subtract the 12x over to the other side. So A is 1, B is negative 12, and C is 36. Okay, I'm not asking you to solve here. Just a quick check. B squared minus 4AC. Let's see what that is. Negative 12 squared minus 4 times 1 times 36. Oh, that gets us 0. What does that imply? That implies one real solution. One real. I'll pull this one up so we can see it. It doesn't take too much work. Same kind of thing here. I subtract the 12x over to the other side. I get x squared minus 12x plus 40 equals 0. So that means I would say A is 1, B is negative 12, and C is 40. So B squared, negative 12 squared again, minus 4 times 1 times 40. Okay, let's see what happens now. Use the same entry, but now it's 4 times 1 times 40. Negative 16. I don't care about the 16. All I care is that it came out negative, which implies 2 non-real solutions. And then I bet you could tell what my last one is. Let's take a look at the last one. X squared minus 12x plus 30. Okay, so A is 1, B is negative 12, C is 30. So B squared minus 4AC here is going to be positive. I don't care about the fact that it's 24. I care about the fact that it's positive. So that's 2 real. Does that make sense? And the discriminant is telling you that. The discriminant is telling you whether it's 1 real, 2 real, 2 not real. Okay. So now we have kind of coming full circle. We can factor, we can complete the square, we can use the quadratic formula, we can solve directly. We have all these different methods of solving quadratics in our mathematical tool belts. Right? We have all these different things that we can solve for. You're going to notice on the practice test tomorrow, I ask you to solve in different methods. Yeah, I'm asking you to show the work for factoring, show the work for quadratic formula, show the work for completing the square, and so on. And so you'll see on there, I ask you to show different methods, but yep, you'll see on the practice test tomorrow. So long, everybody, playing along at home. Did I have my webcam running the whole time? That's so weird. Okay. Hey, everybody at home. Okay, see ya.